Welcome to the video. Transfer learning is a powerful technique that uses the retained knowledge of certain neural network in new tasks that the model isn't trained earlier. So in this video, we are seeing some application of transfer learning method. We know that transfer learning is related to problems such as multitask learning. There are some major rituals in transfer learning that includes pre-trained models, feature extraction, fine-tuning. So by the three constraints, we can change the neural network and train the model as we want. So now we can see what is need of transfer learning. Transfer learning for DL tasks can be helpful in solving tasks that require larger data sets. So we know that we can use image as a data set. So we can modify the image or find the image or find the faces like that. So many applications are used in DA using transfer learning. So here I am used Inception V3 as a model in transfer learning, and I am doing some application of transfer learning. Yeah, this three type of transfer learning: inductive transfer learning, transductive transfer learning, and supervised transfer learning. So here we used inductive transfer learning method. Now we can see the implementation of the code. First, we load the pre-trained model. Uh, Before that, we want to implement the data set or upload the data set to the drive and implement to the model. Then we load the pre-trained model. That is Inception V3. That model is Inception V3 that we are using in this code. So this model is pre-trained on ImageNet. This model will find the image and image specifications. So first, the full pre-trained Inception V3 is loaded to make predictions without transfer learning. Second, we load the model without the top layers or the classification layers so that we can add our own layers specific to CFAR10. So first we use the CFAR10 as the dataset for this model. Then second, we adding custom layers. That is, after removing the top layers, we add a few custom layers. Average pooling 2D, fully connected layers with 1024 units and relief activation function. Then a soft max layers with 10 units, which outputs the probabilities of each classes. Then we are resizing the CFAR10 images. While implementing the code or assumption, while implementing the code, our inception model labeled images did not match. The size of the CFAR10 images as they are only 32 by 32 pixels. But the Inception V3 expects an input of size 299 into 299. We use the tf.image resize function to resize the image while maintaining the original colors and aspect ratio. Then fourth thing is the major step we are used. Freezing layers for transfer learning and predicting an unlabeled image in Inception V3. As we know, in transfer learning, we often freeze the lower layers of the pre-trained model so that the network retains the knowledge learned from a large dataset, like ImageNet. In our code, we freeze all the layers of Inception V3 up to the last 20 layers, which we fine tune after training the new layers. Finally, we are applying transfer. After freezing the layers, we train the new layers we have added to the model using the CFAR10 dataset. Once the initial training is done, we unfreeze the last 20 layers of Inception V3 and perform fine tuning with a low learning rate to improve the model's performance. In transfer learning, one popular approach is freezing method, where we freeze the weights of some layers in the pre-trained model, preventing them from being updated during training. The layers that are frozen retain the learned weights from the original task. Example is imagined, as we know. While only the newly added layers or a few top layers of the model are trained or fine-tuned for the new task. We freeze all the layers in the base Inception V3 model by setting layer.trainable is equal to false. We ensure that the weights of the pre-trained layers remain unchanged during training. These layers retain the knowledge they acquired from the ImageNet dataset and will only act as feature extractor for the new CFAR10 task. After freezing the base layers, we train the newly added layers, average pooling in fully connected on the CFAR10 dataset. During this phase, only the newly added layers are updated, while the frozen layers remain fixed. This training step allows the network to adapt the new task while leveraging the general features learned from imaging. So basically, we are doing an ImageNet model, neural network. So that we used a pre-trained neural network or model called the Inception V3, and we freeze some layers, and we added CFA10 as dataset. Then pre-training the model, or we are using the transfer learning method to the model. Then we are forming a new model as we want. Then we uploaded some images and checking or train the model and testing the model by uploading some image or image. Then output will give the accuracy of the model. Then at last here we have implemented the transfer learning concept using the freezing the layers method by using Inception V3 as a base pre-trained model and used CFAR10 as a dataset for training our new model with the existing model. So thank you for watching this video.